Okay, welcome back to part 3 of this little video series on nomenclature. And this final part, we're going to be going over acids, right? So I think acid naming is a little bit more difficult than our binary molecular compound and ionic compound naming. So we will really get into this. There are 2 types that we're going to be trying to name. So the first one's going to be binary acids, right? And then the second will be oxo acids. So binary acids, just by looking at the name, I see bi, and that means 2. So binary would be 2 elements per 1 acid, right? So these are going to have 2 elements in them. And one of these elements, one element, will be hydrogen. Always. So look out for that. If you ever see a hydrogen plus another element, it's going to be a binary acid. Oxoacids are a little different, right? So with oxoacids, there's different kinds. We look at oxo, and this is going to tip us off that there's going to be an oxygen somewhere in there, right? So there's 2 different options here. For these, you will have a hydrogen plus an oxygen plus a nonmetal, or you will have a hydrogen plus a polyatomic ion. And all of our polyatomic ions contain oxygen. And so that's what classifies both of these as oxo acids, right? So some names for this stuff, it really varies depending on what acid you have. But if we start with binary acids, how we name these is we start with the prefix hydro. So hydro comes first, and then we have the root nonmetal name, right? So whatever hydrogen is paired with is going to be our root nonmetal. And then we're adding the suffix ic, I-C-ic, right? So we can do some examples of these. Let me give you a couple. We're gonna do how about HCl and HBr and hydroiodic acid. All right, so all of these we see have a hydrogen. I have hydrogen here, I have hydrogen here, and the prefix hydro here tells me that I have 1 hydrogen. So I have 1 hydrogen plus another element in both of these. That means that it's probably going to be a binary acid. 2 elements equals binary acid. Awesome. So the first thing I do with binary acids is I add my prefix hydro immediately. Hydro, awesome. Then I'm going to take my root nonmetal name. So I know that my root nonmetal is going to be chlorine, right? So I'm just going to write, yeah, I know this is chlorine, and I want to take the root out of it. So I'm going to take chlor, and I'm going to put it next to hydro. So hydrochlor, and then I'm going to add ic, right? My suffix ic over here, so hydrochloric, and then you add the word acid, right? I forgot to add that, but then you add acid. So hydrochloric acid, that's the first one. If we look down at the second one, I have HBr. This is literally the same thing, just with a different root nonmetal. So I have 2 elements. That's going to make it a binary acid because one of those elements is hydrogen. And I know I have my nonmetal here. So I'm going to start this out with hydro because I know it's binary. Then I'm going to take my other element, take out the root of it. So bromine. I'm going to put bromine, that's fine. And then I'll add ic, bromic, hydrobromic, and then acid. So HBr is hydrobromic acid. Going the other way, right, when they give you the name and they want the formula for it, look for the word hydro. If you have the word hydro, that means it's going to be binary, right? And you're going to have 1 hydrogen. Now you just have to figure out what is the other element. What is your root nonmetal? So come over here and look at this. Iodic. I know that the IC is my suffix. So what element has this iodic as our root name? Well, I'm thinking that it's going to be iodine, right? Iodic equals iodine. Awesome. So how would I write this? I know I have one H. Awesome. And I have one iodine. So it'll be HI, hydroiodic acid. Amazing. So that was binary acids. Now we will move on to our, let me move it down, oxo acids. So there's a few different ways that we have to look at naming these, right? So we have to look, does it end in ate or ite? And when we talk about this, we're talking about polyatomic ions. Most of the examples that you'll be given involve polyatomic ions. Does it end in ate, like carbonate, for example, or does it end in ite, like carbonite, right? So depending on your ending, that is going to change your suffix. If your polyatomic ends in ate, it is going to change it to ic, the suffix ic, which we've already seen, plus the word acid. If your polyatomic ends in ite, it's going to end in us, O-U-S, plus the word acid, right? So we definitely have to know how to name all of our polyatomic ions for this, because that'll determine how we name everything, right? And so let me think up some examples for our oxo acid naming. Let's go H2SO4, H2SO4, how about HNO3, CH3COOH. Yeah, that was good enough. Okay, so the first one, looking here, I see that I have hydrogens, cool, and I also have SO4. That's a polyatomic ion, right? And so I already know that because this is a polyatomic ion and not just one element, that this is not binary. It has to be polyatomic, so we have to follow all of these rules. So there's no prefix hydro. No prefix hydro at all. We just jump right into it. So literally all we're going to do is name our lovely compound here and add acid to it, right? And change our suffix. So pull it out. I know that H2 is going to be our cation over here, and so I have to figure out SO4. SO4, what is that, right? I know I'm going to have a 2- charge, and if I recognize this, this is a sulfate ion. Sulfate ion, and it's negative, so it's an anion, right? So to name this, I'm just going to take that 8 in sulfate, and I'm going to change it to ic. Cool, right? And then I will add acid. So this would be sulfur, right? Because the main non-metal here is sulfur, sulfuric acid. Sulfuric acid. Awesome. So next one, HNO3. Well, I have more than 2 elements, so this is greater than 2 elements, so I know that I'm following my oxo acid naming rules. So my hydrogen will be my cation, and my NO3 will be my anion. So what is this anion? NO3. It's a -1 charge, and I'm thinking that this is going to be nitrate because I studied my polyatomic ions. So this is a nitrate ion. Same thing is going to happen is I'm going to change this 8 to an ic, right? So it'll be, instead of nitrate, nitric acid. Nitric acid, right? Pretty cool. So coming on to the next one, this one looks a little weird, but we can still pick it apart. So this is a very long polyatomic that I hope you recognize as acetate. This is acetate. And it has an extra hydrogen added on the end. This is what makes it an acid, is because we put a hydrogen on it. So if I pull out acetate, it looks like this, CH3COO- and then H+. Now I just have to decide how am I changing our suffixes, you know what I mean, to make this into, to name this compound. So I'm going to take that 8, I'm going to turn it into an ic, and I'll take the root of acetate, so acid, and then add ic, so acetic acid. Pretty chill, right? Let's see if I can come up with another one. So NO3, NO2. We could do HNO2. HNO2. So this one's similar to HNO3 up here, number 2, right? But it's just slightly different. So I know that HNO2, if it has an H and a polyatomic ion, it's probably going to be an acid, and it's going to follow our oxoacid rules. So I'm going to pull out this anion and see if I can name it. NO2-. This is nitrite, a nitrite ion, right? So if I'm going to name this as an acid, I'll change the ite to us, O-U-S, and I'll add acid. So take that root, nitrous, acid. Simple enough, right? So that is the end of acids and my nomenclature videos. Hopefully you all got it, and good luck studying.